domain of f be in this case? -1, 0, 1, 2. Now, yesterday we worked on set builder notation. We talked about writing things in sets. I want to use that notation to write my domain. So I'm going to say my domain is the set of all x's such that x is in the set -1, 0, 1, or 2. Okay? That's different than just, you're used to just writing it probably as a solution set. Basically all you wrote is the inside portion. But we're trying to use the whole set builder notation here. So the range, that's going to be the set of all y's such that y is an element of the set. What can my y be?
2, 1, 5.
2, 1, and 5. Alright, is that okay with everyone? Okay, so let's practice finding domains and ranges of our functions. So domain, that's our input. Range would be our output here. So the first one. First, do you remember how to read this? From yesterday, what's this mean? Okay, it says we have a set of all ordered pairs, x comma x squared plus 1, such that x is a real number. So in other words, ordered pairs in this. If I put in 0, I would get out 1. If I put in 1, I get out 2. If I put in -1, I get out 2. Okay, and we know as long as my x was a real number, I could put anything in. So the domain, that's my input values. What can I put in for my x?
Could be 0, 1, -1.
Well, these are just some sample ordered pairs that I pitched. But for this entire set, what can I put in?
All numbers.
All real numbers, right? So my domain is going to be the set of x such that x is an element of the reals. My range. What kinds of answers do I get out?
Positive ones.
Positives. Can I ever square something, add 1 and get a negative?
No.
No, I can't get a negative. Can you ever square something, add 1 and get 0?
No.
No. What's the smallest number we'll ever get? 1. So if you wanted to write that using our new notation, we'd say we have a set of y's such that y is greater than or equal to 1. Okay. The biggest thing here is getting used to this new notation. Does everybody understand what that means? Alright, so take a second. I want everybody to try to write down the domain and range for part B. So for A, or for the domain, I know that x can be any real number. I'm going to put it in here and square it. My domain is the first component, so it's going to be everything that shows up in the first value of my ordered pair. What kind of numbers will I get?
Only positive.
Only positive? What's the smallest one we'll get?
0.
0. So how do you write it?
X. Greater than or equal to 0.
So you'll say the set of x such that x is greater than or equal to 0. The range. You're going to square it and subtract 1. So how would I describe my range? Why -1?
Just you're subtracting 1.
We're subtracting 1. We know the biggest this could, or the smallest x squared would ever be would be 0. Minus 1 would give me a -1. Alright, is that okay? We need to get used to some terminology. When I ask you for the value, that's your y. So f of x is the value of a function f at x. It's the y value when you have a specified x variable. So let's say our function phi is 1a, 2b, and 3c. So the value of phi at 1 is what? A. Just give me the y. Or another way of writing it, phi of 1 equals A. Okay? So we're going to start using lots of different words, and we'll talk about whether that means I'm asking for the x or the y. If I ask for the value, that's asking you for the y. Okay, so value means the y. So, let's say f of x is a set of ordered pairs x, y, such that x is a real number and y equals 4 minus x squared. I want you guys to find each of these. I'll do the first one, then I'm going to make you do them. So f of 1, what's that mean I need to do? Plug 1 in. In other words, I'm finding my y, which is 4 minus x squared. So 4 minus 1 squared, which would be 3. You guys do the rest for me. Okay. F of 0 is 4 minus 0 squared, so that would be 4. What's f of 2? 0. You have 4 minus 2 squared, which is 0. F of negative 2 is still 0. Order of operations, you're going to square it before you subtract, so that takes care of your negative. F of A, can you do anything about that? No, so it's just going to be 4 minus A squared. F of 2 minus A. So if we plug that in, what do we have to do there?
Foil.
Foil. So we have 4 minus, when I FOIL that, I get 4 minus 4A plus A squared. What do I need to do with this negative? Distribute it out. What happens?
Worst case, negative x squared.
Yeah. How's that? Good? Alright. So, you guys are comfortable with evaluating functions. We kind of talked about what a function is already, but another more formal definition than what we've had so far. A function is a rule which assigns to each member x of one set a unique member f of x of a second set.
Are you going to write this down?
You might want to. This is the definition that you're going to use most often. So the function is the rule itself that tells you how to get from your input to your output value. That's what a function is. Okay. So we don't always have to use set builder notation. There's another notation that's sometimes used. We need to look at it as well. So on the previous example, what I used for a function, I used set builder notation. I told you my function was the set of all the ordered pairs x, y, where x could be anything, but y was 4 minus x squared. The other way to write this is as a mapping. This says you have a function x such that every x is mapped onto 4 minus x squared. Okay, you need to know how to read all these different notations because they all show up. So our function is f. Every x goes to 4 minus x squared. Right. You guys, are you comfortable with that notation? The part before the arrow, that's your input or like your domain. Part after the arrow, that's your output or your range. Another way, the way we most often see functions written is just as an equation, f of x equals 4 minus x squared. That's the way we see it in college algebra, algebra 2, most common. We can also write it, if I don't tell you the name of the function, you could just say x goes to 4 minus x squared. Here I haven't defined the actual function, but I'm telling you the rule. You take an input to get your output, you just do 4 minus x squared. So several different forms we may see the same problem written in. Are we okay with those? Okay, if I don't tell you otherwise, we assume that all functions have a domain of all real numbers. unless I tell you different or we have some domain problems. We can't have functions that are undefined. Okay, so if your function is undefined at certain numbers, we have to delete those or take them out of our domain. So what are the two cases we're going to have domain problems?
Variable, radical, and variable.
Right. So the denominator of a fraction cannot be 0. You want to write these down. There's only 2 rules. You've used them for years, but everybody seems to forget them. So write it down. 2 things you have to worry about when you're finding domain. If you have a fraction, the denominator can't be 0. And let's see, how do I want to phrase this so you know what I'm talking about? For even radicals, the radicand, that's the part underneath the radical, has to be greater than or equal to 0. Okay, if it's an odd radical, like a cube root, a fifth root, it doesn't matter. You can do the cube roots of positives and negatives. But if we have an even root, it has to be positive underneath. All right, is that okay? So let's find the domains. That's where we're going to end today, practicing with domains. Our function is 1 over x minus 2. So I have a fraction. What do I have to worry about? Right. So I know that x minus 2 can't be 0, which means x cannot be 2. We agree with that? Now we need to write this using our set builder notation because we're practicing that right now as well. So I am going to say my domain is the set of all x values such that x is not 2. And that's it. Would you take a second and try this one? This is 1 over x squared minus 1. Okay, so what do we have to look at here? The bottom. So we know that x squared minus 1 cannot equal 0. How'd you solve it? If you square root, what do you add along with that? Okay, so my domain is the set of all x's such that x cannot equal plus or minus 1. Or you could say x cannot equal 1 or negative 1. That would be fine. You don't have to write them together. Alright, is that one okay? One more. Okay, this time I gave you a radical. What do we have to worry about if we have a radical? Okay, you have to look at the radicand part underneath the radical, and what has to be true about it? Right, so we're going to say x minus 2 has to be greater than or equal to 0. It cannot be negative. So if I solve that, I get x is greater than or equal to 2. So my domain will be set of all x's such that x is greater than or equal to 2. Is that okay? All right. What if, okay, put in something more challenging here. Let's say f of x equals the square root of x squared plus 5x plus 6. I'm going to put a couple be true about that part under the radical? Okay, so x squared plus 5x plus 6 has to be greater than or equal to 0. If you were trying to find out when that equals 0, what would you do? Box method. Okay, since it's a 1x squared, I'll go ahead and do it as a shortcut. So x squared breaks into x, multiplies to a positive and adds to a positive, so both positive. Well, we multiply to 6 and add to 5. Okay, I'm multiplying two things and getting a positive answer. That means they could both be positive, or they could both be negative. What do we have to make to figure out when the signs are 1 to 1? Sign line. We need a sign line here. Anytime you have two things multiplied or divided, an inequality would make a sign line. We put on here what would make each of these 0. So what makes x plus 2 equal 0? I'm going to put -2. What about x plus 3? Now test points. Give me numbers smaller than -3. -4. In between, maybe like -2.5. And bigger, like 0. These are just test numbers. We're going to plug them in up here and see if we get a positive or a negative. So if I put in -4, I have a negative. -4 plus 3 is negative. And negative times a negative is positive, right? If I put in -2.5, -2.5 plus 2 is negative. -2.5 plus 3 is positive, so altogether that is negative. If I put in 0, 0 plus 2 is positive, 0 plus 3 is positive, so that one is positive. You remember doing these?
Get a drink.
I want greater than or equal to. So do I want positives or negatives?
I'll bring it back.
Positives. So I want those and those, because those are the intervals that came out to be positive, correct?
32.
So, my domain is a set of x's such that, how would I describe this piece? X is less than or equal to -3, because that's where it equals 0. Or, this piece I would say is greater than or equal to -2. Those sign lines, it's probably been a while since you've done one of those. So this is a good review. You may have done it now, number 2. Maybe not.
I don't remember.
Okay, well, let's do another one then.
Fine, I remember it now.
Okay. So, B. I know the part underneath the radical has to be positive, correct? Alright, I have two things divided that has to be positive. It's same as with multiplying. They can either both be positive or both be negative. Only way to decide when it's going to work is by making a sign line. What would make the top of this equal 0? 0. What about the bottom? 3. Okay, test points. So smaller than 0. In between. Bigger. Does everybody understand how I get the 2 points on my sign line and all my test points? Especially since you don't remember doing these before. Are you okay with that part?
Yeah.
Okay. We're just going to plug them in now and see if we get a positive or a negative. So, -1 would be negative. -1 minus 3 would be negative. And negative divided by negative is positive. If I put in 1, that would be a positive over 1 minus 3 would be negative, so that whole piece is negative. 4, so I get a positive over a positive, so that is positive. Which ones did I want? Positives. And it said it could equal 0, so we think both of those could be equal. But I have a problem. What is that?
Greater than or
be greater than or equal to, but we have a fraction. We also know that in a fraction, the bottom can't be 0. What would make x minus 3 equal 0? 3. So it cannot equal positive 3. That would give me 0 on the bottom of the fraction.
So it has to be greater than 3.
Right. So this domain set of x such that x could be less than or equal to 0 or greater than 3. Is that okay?